tell everyone a little bit about yourself.
All right. My name is Evan Kane. I am a licensed geologist, and I'm the manager of the Groundwater Protection and Wells section of the Wake County Department of Environmental Services. We are, despite the name, we are essentially a part of the local health department for Wake County, and we regulate and inspect private drinking water wells and any other private domestic wells in the county, and also provide technical assistance for well users throughout the county. I'll go into more about me and my programs as this presentation unfolds, but Hayden, do you want to give yourself a quick introduction too?
Yes. Hi, I'm Hayden Rudd. I'm a PhD student at NC State in the College of Natural Resources. I'm working on research related to groundwater quality. And before PhD, I also got my master's at NC State, and I did undergrad at Furman University. My major was in chemistry and a minor in environmental studies. Between undergrad and grad school, I did an AmeriCorps program in California where I worked with local government on groundwater supply and quality issues. And then I worked at the EPA on drinking water quality. I'll let you take it back over.
Right. Thanks, Hayden. And I'll thank both Hayden and her advisor, Dr. Elizabeth Nichols, for inviting me to join them. They actually got the invitation to give a talk here, and they brought me in, which was nice of them. But with that, I'll give a little bit of background and context. One of the things that surprises people sometimes when we say private wells in Wake County is private wells in Wake County. I thought, you know, we're the Research Triangle and we're an urban county and so forth. But in fact, Wake County is sort of a microcosm for the nation as a whole, in that 15% of Wake County residents rely on a private drinking water well at home. So 85% of our population depends on public water systems. These are systems that are regulated under the Safe Drinking Water Act. They serve 15 or more connections, and they range in size from a subdivision with a single well serving 30 homes up to the City of Raleigh system, which serves Raleigh, Rollsville, Garner, Zebulon, Wake Forest, Wendell, and serves several 100,000 people. Those public water systems, being regulated under the Safe Drinking Water Act by the North Carolina Department of Environmental Quality, have requirements like they have to have certified operators to run the system. They have regular testing requirements, and they have regular monitoring and maintenance requirements on the system. Private wells, on the other hand, these are wells serving fewer than 15 connections, generally one, maybe two or three homes might be connected to a single well. And in Wake County, we have been permitting these wells and doing some level of inspection and testing of these wells since 1987. We were one of the first counties to do so. And we were actually the model for a program that was put in place in 2008 statewide for all local health departments, county health departments, to regulate the initial construction and siting of private drinking water wells. But the regulation only goes so far as that initial siting, construction, and initial testing. Once that well has been put into place, or if it predates our permitting and inspection program, the responsibility for testing, maintenance, and so on is up to the well owner. And so we like to encourage well owners to think of themselves as water system operators with all the responsibilities of one of these certified operators of a public water system, but without the regulatory framework around it. So a lot of my talk will kind of focus on that idea as a way of helping educate anyone about aspects of private wells, well water safety, and so forth that are important to know. So whether you're a well owner or not, hopefully that framework will be good for helping you understand these systems. And, you know, the other thing we like to do is dispel any stereotypes people might have about the types of housing and living situations that are served by private wells. You might think of maybe a mobile home on a sand path next to a farm in the rural area, and certainly we have those in Wake County. But we also have, you know, mid-60s ranch houses and even subdivisions that have been built in the last 20 years, and even new subdivisions being built today in Wake County that are being built with private wells and individual septic systems. And though it's a very small number, we even have a handful of private well users within city limits in areas that are currently served by city water. The example here, you may notice here behind the mailbox, there is a fire hydrant. That is a fire hydrant connected to the City of Raleigh's water system. And right behind here, we see the fiberglass fake rock that is covering a wellhead serving the house out of view to the right, who simply chose not to connect to the City of Raleigh's system when their neighborhood was annexed back in the early 1980s. So private wells serve every demographic in Wake County, every income level. Everybody you can think of in Wake County. There are lots of different types of people being served by private wells in Wake County. Now, I mentioned I'm a licensed geologist, and a few minutes before the talk began, I also mentioned my grandfather was a geologist before me. He chose geology because he thought science education was so important. And since I know we've got some environmental educators in here, I thought it'd be good to mention that and pay a little homage to him, and also to know that he would be ashamed if I didn't bring in a little geology lesson to this talk and even bring in some rocks. It's unfortunate we can't do this in person because we'd have lots of rocks to go around the room. But just to get our bearings, Wake County is located in the Piedmont physiographic province of the eastern US. And because of that location, it has some aspects to the geology and to the groundwater system that are quite different than what you would find just 50 miles to our east in Wilson, or a little bit farther east where I grew up in Greenville in the coastal plain. Within the county, our basic geology consists of sedimentary rocks of the Triassic Basin in the west, shown here in green. High-grade metamorphic rocks, generally gneisses and schists in the central part of the county. An example being a biotite schist for the earth science teachers there. And then to the east, we have the single largest body of granite east of the Mississippi, the Rollsville granite, makes up a good chunk of the eastern part of the county. And then in the very corner out there by Five County Stadium, we have what's known as metavolcanic rocks. These are low-grade metamorphic rocks that originally were things like ashfall deposits from volcanic island arcs that existed over 500 million years ago. And that geology lends itself to a unique aquifer system that is very much unlike what you would find in the coastal plain or what you might find in a general earth science textbook when you look up groundwater and you think about, you might find in those general coverages of groundwater, they talk about sort of a layer cake aquifer system of sand and gravel and things like that. Our aquifer system is quite different from that in that those rocks, those metamorphic and igneous rocks, have no original porosity to them. And so they're actually impermeable to water in their solid form. But over time, over millions of years, those rocks have been fractured by tectonic forces, weathered by rainfall and infiltration of water into fractures, and chemical activity, biological activity, and produce a sort of a profile that you can see here. This is from a drilling site that the North Carolina Division of Water Quality installed in Wake County years ago. But we can see here at the top, what you might be used to seeing under your feet in Wake County is a lot of red clay, maybe some silt and sand and things like that. But gradually, as you go down, you begin to see chunks of rock interspersed with sandier zones. And finally, towards the bottom, we get this good, hard, fresh rock that, makes a nice ringing noise when you hit it, but has intervals of fractures. And those fractures, we can see, here's an example from a drilled core like this. Those fractures are where the water moves in a fractured bedrock aquifer system. And so conceptually, it looks kind of like this. You have a soil zone at the top that may become saturated towards the base as you get to the hard rock. But the really good, clear water that you want for a water supply well is going to be down here in these fracture zones. And looking at that in sort of a larger conceptual diagram, we can see that there's some saturated water here in this weathered zone and fractures throughout. And those fractures may be connected to other fractures. And those fractures can be very large and wide, or they can be very tight. So in this diagram, there's a well shown here conceptually, has solid pipe called casing that runs into the ground. It's required to be set 5 feet into the bedrock. And then below that, it's actually just an open hole drilled into the hard rock. And wherever fractures that have water intersect that hole, water comes into the well and can be pumped out. In the example we've shown here, this well is intersecting a pretty big, wide open fracture, and so you might expect that that well would yield quite a bit of water. But if we look at different locations within this diagram, maybe move over just a little bit, we can see you might choose to drill a well here and intersect very few fractures and very tight ones at that. And so we can have situations in Wake County where one neighbor has a well with a quite high yield, maybe 20 gallons a minute, and right next door they've got 1 or 2 gallons a minute. And with that will also come variations in the chemistry of the water based on what minerals are present in those fractures and how well they're connected, how much circulation happens, so forth. And we can just imagine a couple of other wells in this landscape and think about how different those wells are in terms of the fractures they intersect and how well those fractures are connected to other fractures. Another thing we can think about if you're thinking about the movement of water on the landscape is that in order for the pumping for a well over here on this side of the stream to impact the well that's over here on this side of the stream, you'd actually have to pull in enough water that this stream in the middle would begin going dry. And so we think about, when we think about groundwater flow in the coastal plain, you think about things that aquifers where water can move very slowly, but can be moved and connected over miles and miles, where typically in the Piedmont, most of this groundwater movement is happening over fairly short length intervals. Somebody give me an audio check just to make sure I'm good.
You're good. We can hear you.
Okay. All right. I'm hearing some pinging that may be telling me my network isn't so great. Okay. So that's a little bit about groundwater movement. Now we'll kind of shift gears to talk a little bit about groundwater quality. One of the big things about a fairly urban or suburban county like Wake County is that there's been a lot of human activity, a lot of commercial activity over the years. We have in Wake County over 2,300 known instances of releases of contamination, whether it's from petroleum storage tanks at gas stations, dry cleaning operations, pre-regulatory landfills, and other types of industrial sites. And we have instances where well users have been impacted by those. Anybody who's been in the county and paid attention to private well issues for the last 10 years may have heard of an incident called Stony Hill in northern Wake County, where a contamination incident that was known to the state and to the county was thought to be under control and well documented actually turned out to be not well delineated and impacted quite a few wells in a fairly new neighborhood right behind the contamination site. The response of those neighbors to learning that their wells was contaminated was pretty resounding that, hey, we understand as well users, there's certain amounts of maintaining our water supply that are up to us, but if we had only known, we might have protected ourselves sooner. And so in response to that, the county actually created a program to identify potential contamination sites and well users near them and notify them about the potential for contamination. And we've been working through those many sites and trying to prioritize those and building campaigns around, how do we make sure that every well owner knows what they ought to test for and make sure that we don't create other situations like that Stony Hill incident. Some other man-made sources of contamination that don't get the news quite so much would be animal waste, septic failures, over-fertilizing of lawns, and pesticide use, both on house foundations and on farms, as well as just poor well construction and maintenance. And I like to show this picture here on the right, where you can see this kind of rusty water coming out, and maybe this wellhead looks a little rusty and not ideal. But to me, as the hydrogeologist, I'm looking at this fuel can in the back that's being stored in the well house and thinking about how many times fuel has spilled while filling the lawnmower right next to this well. So those are kinds of things that we think about in the realm of private wells and that well owner as system operator. In addition to that, we also have natural sources of well water contamination, and I'll talk about these in fair detail here. Of keen interest to us is the issue of uranium and radon in wells in the eastern half of the county. The map on the right shows a detailed geology of the county with several hundred well test results for these radionuclides overlaid on it. The red dots are obviously the bad ones. But we also have natural sources of iron and manganese. That's pretty ubiquitous within North Carolina. And you can even have excess levels of fluoride in well water. That one's pretty uncommon, but I mention it because typically people think about fluoride and children's oral health, and they think, well, municipal water has fluoride added, so that's, better for children's teeth, and well water doesn't have fluoride added. But it's always important to check before you assume and add fluoride treatments for children, because sometimes there can be actually excess fluoride in well water naturally present. Now, taking all of that information about man-made contaminants, natural contaminants, and so forth, we, as I mentioned, built this program for alerting people to contamination incidents near their wells. And while we were trying to prioritize where, which sites do we work on next, what approaches do we try, we looked at our data. And we were a little surprised by what we found, and I think most people would be a little surprised by what the data actually shows. This graph shows the percentage of well test results that we've taken that exceed a drinking water standard. And what you might think about in terms of all those man-made contamination sites is things like TCE, trichloroethylene, which is a solvent present at the Stony Hill site. Dieldrin was a termite treatment used on house foundations in the mid-20th century. Fecal coliform is often mentioned as a potential health hazard with private wells. But what really stands out in this is that all of these things, despite intensive efforts to investigate chlorinated solvent sites specifically and termite contamination sites specifically, we have maybe 1 or 2% of wells exceeding standards for those man-made contaminants. But when we look at the naturally occurring uranium and sort of a proxy measurement for uranium gross alpha activity, 10 to 20% of the water samples that Wake County has taken exceed drinking water standards for those contaminants. So very quickly for us, that shifted our priorities in terms of where we go after the most aggressive outreach. We're still very concerned about the Stony Hill situations and things like that, and we have other programs in place to try and prevent those from arising. And we've built testing packages so that people get the tests necessary to detect that Stony Hill type of situation, whether we've sent them a specific letter or not. But these are certainly a high priority for us, these radiological contaminants. And I'll just step back here and give us a national view, since I mentioned that Wake County is a microcosm for the nation in terms of private well use. The USGS published a study several years ago documenting 13 years worth of well testing of private wells all across the country. And what they found was that the contaminants most often found above human health benchmarks were inorganic chemicals derived primarily from natural sources. And we can parse that out and get some insights into the importance of Hayden's research, which we'll get to in a bit. But what I want to emphasize there is that natural sources actually, in terms of known contaminants with known health risks, natural sources really outweighed everything else that the USGS was testing for in these wells. So with that background, I'm going to shift back to that idea of a well owner as a water system operator and talk about what a well owner needs to know. If you are a water system operator for one of these public systems, you have obligations to protect your supply, to ensure there's adequate supply, to respond quickly to problems if there's a disruption or a contamination issue, something like that, and to protect your consumers from unsafe water. And I think it's worth well owners adopting a similar mindset in terms of managing their wells. So protect your supply. What does that mean for a private well owner? For one thing, in terms of the activities on your property, you want to keep a good 50-foot buffer zone around your well. Really kind of leave it alone. Don't plant things around it that need a lot of spraying or fertilizing, and don't keep that gas can in the well house, things like that. Maintaining your septic system to make sure it's functioning properly and breaking down harmful bacteria and nitrate and things like that, and keeping that out of the groundwater system. And if you see visible septic failures, wastewater surfacing above a septic system, the Wake County Department of Environmental Services can respond to those failures, inspect, and determine what needs to be done with that. And then in terms of protecting your supply, regular well testing is an important part of that. Knowing what's going on over time with your well and whether there are issues coming up with that well. You also want to protect the well itself from physical damage. If you're putting additions on your house or doing landscaping, keep your driveways and your parking area well away from your well so you don't wind up with a situation like this of a broken supply pipe gushing water all over the yard. Make sure you have legal control or access rights to the well. And you'd be surprised how often this comes up, that a well that was shared starting off maybe 40 years ago between family members who live next door or friends who live next door to each other, one house gets sold into someone who's not part of that original sharing arrangement, but there's no legal document that documents that sharing arrangement should be in effect. And maybe the neighbors don't see eye to eye on an issue, and the person who has the well on their property just shuts off the next door neighbor. Doesn't happen much, but it does happen occasionally. So if you're using a shared well, maybe bring some cookies over and talk about an access agreement with your neighbor. And then if you take a well out of use, you connect to city water, you drill a new well because the old one has gone out of service, become unuseful. then have that old well permanently plugged to create, so it doesn't create a safety hazard or a contamination risk in the future. In terms of ensuring adequate supply, there's droughts that we can't exactly control. There may be competing users of the water resource, and you may have limited ability to control that, but there are a few things you can do. And I like to think about groundwater as a savings account. The water that falls from the sky, that's income. And so what we want to be doing when water falls from the sky is we want to be getting it into the ground wherever we can, so that we help recharge and make deposits into that savings account. So watering wisely, water-saving toilets and appliances are important, and just generally promoting rainwater infiltration by limiting paving, limiting soil compaction. That means don't drive all over the soils on your property if it's not paved. And think about putting in low-tech rain gardens to address driveway and roof runoff and help those sources of savings infiltrate into the ground. And just, you can also think about rain barrels and cisterns to use for outdoor irrigation as an alternative to using your savings account of that well. An example here of a rain garden installed in someone's front yard to take their roof runoff and help that soak into the ground. In terms of responding quickly to problems, for a private well owner, first and foremost is know who you're going to call when there's a problem. So get to know a well contractor and a pump installer. If that pump burns out, lightning strikes, something like that, know who you're going to call. And one place to go is go to the wellhead and see if there is still a tag on that well, and it will identify who installed it, who installed the pump, and you'll be surprised how many years worth of memory those individual well contractors will have about a specific well. Make sure you do hire a certified, registered well contractor or registered pump installer. And you can find those contractors listed on our website at wakegov.com/wells. And then in terms of responding quickly to problems, just adopt a mindset that free water, you don't pay a utility bill on a well, it isn't really free. As a well owner, you're ultimately going to be responsible for the repairs and maintenance, so you can plan ahead and sort of pay yourself a water bill. There are financial assistance programs available, but they are somewhat limited, and they will depend on your income, age, or disability. But we have information about that on our website as well. And finally here, protecting consumers from unsafe water. So what does that mean? Regular well testing is key to this. If you've got clear water that tastes great, well, I'm happy for you. If you've got cloudy water or staining, you've got blue stains, you've got hard water, your water doesn't smell like anything, it smells good, it smells bad, all of those are situations where you should have your well water tested with a certified laboratory. It's really the only way to know for sure that your water is safe. So what testing? The next question is always, well, what testing should I get? And so one of the things we recommend countywide is something we've called the First Timers Package. If you order well testing from Wake County, you don't have to know all the technical names of these things. You can order the First Timers Package, and it will include coliform bacteria, heavy metals, nitrate, and other inorganics, including fluoride, volatile organic compounds, that includes those chlorinated solvents as well as petroleum contaminants, and a limited number of pesticides that we have found in wells in Wake County. If you are in the eastern half of the county, we recommend that you do that First Timers Package, but also that you get what we call the Rads package, which includes testing for uranium, gross alpha activity and gross beta activity, radon in water, and a test kit for radon in air. We know that 1 in 5 wells in this part of the county will have problems with one or more of those contaminants. And again, that makes that the highest the highest rate of problems of any health-related contaminant that we find in wells in Wake County. And if you just happen to be joining us from another county, just understand that the geology doesn't stop at the county line. Franklin County has similar geology to Wake County, including these granites that are responsible for the uranium and radon issues that we have in eastern Wake County. And if there is a problem, what do people do? Well, the county can help with explaining what the results mean, and we can identify options for you. Unfortunately, we don't have a bailout program like that, but we can help point you to resources, including regulatory programs with the State Department of Environmental Quality. And as a well owner, know that nearly every water quality problem that we find can be fixed in some way. It's just going to depend on, what the particular problem is going to dictate how much it costs and what you need to do to fix it. And again, there is some financial assistance available. If you want more information about our program, you can go to wakegov.com/wells or call our customer support number 856-7400 and connect to one of our staff members who can answer lots of questions about your particular issues with wells.
And we did have a question in the chat.
Yeah.
So one of our participants stated that they use well water only for watering their garden. Should they still be testing it? And is there anything in particular they should be testing for?
Well, I love data, so I'd love for them to test their well water. So I have another data point. I think, we have these sort of blanket recommendations for people who are using private wells as drinking water supply. But any kind of testing that goes beyond, if you're not using that for drinking water supply, then yeah, there might be some different or more limited testing that you need. It would be helpful for you to know, what is are there fecal coliform bacteria in that well water? Is there nitrate and excessive minerals and things like that? So with an irrigation well, you might be able to get by with simply a coliform bacteria and inorganics testing. Certainly, you might look around you and see, are there gas stations nearby and other commercial activities that might have created other man-made contaminants in the ground, and think about those volatile organic compounds and things like that. If your house was built in the mid-20th century, there's a good chance that some termiticides were used on that house foundation that we have found in some wells in Wake County. So that might be something you want to add in terms of the pesticide analysis. And, if children are playing in that, in the sprinkler or something like that, you probably want to know whether there's infectious bacteria and so on. But generally speaking, I'd consider you a great model citizen if you got very comprehensive testing on that irrigation well, but it may not be absolutely necessary. Other questions for me right now?
Not in the moment. Not at the moment. I'm sure there'll be some more towards the end.
All right. Well, I think at this point it'd be good to transition to Hayden's presentation, and I have that loaded up if you want to just call out the slide changes, Hayden. I'll just preface it by saying, I've mentioned these radionuclides a lot. The reason we emphasize them is because we collected some data roughly, 10 or a dozen years ago that showed us there was a problem. And so the importance of studies like what Hayden is doing is that they help us inform what we tell well users that's necessary to protect their health and so forth. And of particular interest to me is with the research that Hayden's going to be doing here is one key phrase from that USGS study, that they were comparing the contaminants that they tested for to things with known human health risks, with human health benchmarks. And I don't want to give away too much of what Hayden is going to talk about here, but what I talk about and what I work in on a daily basis is in the known human health risks. And Hayden is going to be helping kind of push the envelope here and enlighten us more on sort of more of the unknowns. And I'll shut up and quit stealing your thunder, Hayden.
No, you're good. Thank you for the intro. So as Evan said, I'm going to give a little background and then discuss a study that NC State and Wake County are working on together. So you can go to the next slide.
Okay.
So under the Safe Drinking Water Act, drinking water is tested for biological agents, radioactive elements, metals, nutrients, and several different types of organic chemicals, all using specific EPA tests. And our study that we're doing with Wake County is focused specifically on organic chemicals. And as this pie chart shows, there are many different types of organic chemicals regulated by the EPA for drinking water. And detecting all of these organic chemicals requires multiple different tests, and they can be pretty expensive. So this presents a big challenge for private well users who, as Evan has described, are responsible for testing their own water. Next slide. This table here lists all 53 organic contaminants that are regulated by the Safe Drinking Water Act. And in this table are a variety of chemicals with different sources, different structures, and this is why some of them require different tests. For instance, the concentration of the herbicide atrazine and pesticide endrine would require, or could be evaluated using the same test, but a different test would be needed to test for the concentration of dioxin, which is shown on the right side, and is a byproduct of combustion. And then a third separate test would be needed to evaluate vinyl chloride concentrations. So you can see how this can start to get pretty complicated if you're worried about a variety of different organic contaminants. Next slide, thanks. So due to this challenge, our study is focused on a new screening technology called high resolution mass spectrometry, or HRMS. So most EPA methods use standard mass spectrometry to test for contaminants. But this method is limited to evaluating one type or group of chemicals at a time. For instance, it could be used to evaluate the concentration of several pesticides at once. But it often results in few or no detections of chemicals. In contrast, HRMS conducts a broad scan of the chemical features that are present in the sample and then uses chemical databases to determine their identity. So in a recent study of groundwater, HRMS detected an average of 5,000 chemical features per groundwater sample. Of those, 30 on average, 30 organic chemicals on average were identified per sample with a 90% confidence level. So HRMS screening, while it doesn't provide chemical concentrations, it does tell us the presence and absence of a variety of organic chemicals. And it shows a great promise to be used as a diagnostic tool that can detect more chemicals with one test and detect those chemicals at lower concentrations than standard methods. Next slide. So NC State researchers, myself included, did a recent study where we used HRMS to evaluate organic chemicals in monitoring wells from the North Carolina Department of Environmental Quality's Monitoring Well Network. And this study helped to illustrate the strength of HRMS. So during this study, we sampled 150 wells and we found 4 different safe drinking water contaminants in at least one groundwater sample. Specifically, di-2-ethyl hexyl phthalate was actually found in 16 different samples. Along with the HRMS evaluation of the samples, we also used that standard mass spectrometry method, or the standard EPA method. And using that method, only one safe drinking water contaminant was detected in all of those samples. Di-2-ethyl hexyl phthalate was found in one sample, and that was it. And no other safe drinking water chemicals were detected. So this illustrates just how HRMS can help us to detect regulated contaminants early when they are still at a concentration that might be below the drinking water standard. Next slide. In addition to early detection of regulated chemicals, HRMS can also be useful for detecting emerging contaminants. And emerging contaminants are chemicals that are not currently regulated, but that are of concern to regulators. And some common characteristics for emerging contaminants are chemicals that are persistent in the environment, those that bioaccumulate or biomagnify, chemicals that might be toxic to humans or to the environment, or chemicals that are widely and constantly used by society. And some common emerging contaminants include pharmaceuticals like ibuprofen, PFAS and PFOS chemicals like Gen X, personal care products, and fragrances. Next slide. So in that previous HRMS study that I mentioned, where we sampled NCDEG wells, we detected an average of 9 emerging contaminants per sample. And the 10 most common detected are listed here. As you can see, the 3 most frequently detected emerging contaminants, which are D-triphenyl phosphate and diethyl phthalate, were each found in over 50% of all of the groundwater samples that we tested. So this just illustrates just how powerful HRMS is as a tool for detecting these emerging contaminants that are not evaluated in standard EPA methods. Next slide. So now that you've gotten a little background on this, we can talk a little more about our project that we're just starting. So NC State and Wake County are starting this project, and we have 3 main goals. The first is to use HRMS to test for organic chemicals in water samples from private well users in Wake County. The second is to provide well users and Wake County officials like Evan with information that can help them make decisions about well water testing. And then finally, we're hoping to evaluate how to use this HRMS technology to determine how useful it is for well users and for public health officials when they're making decisions about well water testing. Next slide. So, as I said, we're just getting started. I'll walk you through what we've done so far and then what we're planning to do. So we started by sending out an advertisement in Wake County's private well user newsletter, soliciting volunteers to participate in our study. And luckily there's been a great response rate so far. And so we're gonna have plenty of well users to conduct this study. So we're gonna be selecting participants soon and then scheduling a time to visit each well user to collect a home water sample and conduct a brief interview with them to understand their beliefs and knowledge about their well water quality before any testing done during this study. And then once we've collected those water samples, we'll use HRMS to analyze the water samples for the presence of organic compounds. And then once those samples are analyzed, we're going to create a report for each well user with the results of their water sample along with a comparison to HRMS results of a municipal water sample, just for reference. And then we're going to schedule one-on-one meetings with each well user to go over their results and to conduct a follow-up interview to ask questions about how useful this information was and to evaluate how their beliefs and knowledge of their groundwater have changed. And then once we've gone through all the individual well user results, we'll aggregate those and create a summary for Wake County. And then we'll share that summary of results with the Wake County staff and similarly conduct interviews with those staff members to assess how the information impacts their attitudes and decisions about private well testing and to hopefully see how this information can be used to help improve their recommendations for water testing. And by reporting back our results to both well users and to Wake County staff, along with conducting these interviews, we hope to learn how to improve researchers' use and communication of HRMS results to help private well users and public health officials with well testing. That's it. Please let me know if you have any questions about this project.
Thank you, Hayden. So at this point, we'll open it up to the floor for questions. You are welcome to use the chat. There is a raise hand feature. So towards the top of the screen, you'll probably see a smiley face with a hand. You can use that, or you can just kind of unmute yourself. I do have a question for you that was thrown in. And you had said earlier on that most well problems can be remediated. So what is done for radioactive elements in the water?
Yeah, so there's fairly simple technology for that, depending on the levels of the contamination. It could be as simple as a reverse osmosis cartridge that's installed in the kitchen to treat the water where most of the water for drinking and cooking is used in the home, or it could be essentially a sophisticated water softener using two types of ion exchange media that treats all the water coming into the house. If there are issues with radon, which is a gas, then you may need to add in typically an aerator, which actually blows air through the water and vents the radon outside the house before it goes out into the plumbing of the house. So in the case of radon, that radon will be vented to the outside where it's diluted and no longer a threat. In terms of things like uranium and radium, there is periodic backwash of those filtration systems that is then discharged onto the ground and soaks into the ground again, which is where it came from to begin with. So we're not talking about building up large amounts of radioactive material that have to be disposed of or something like that. You're not turning your house into a radioactive waste site. There is another technology used for radon sometimes called activated carbon. And there are certainly perceived and possibly real risks to activated carbon systems that stay in service for too long and the radon builds up and continues breaking down into other radioactive elements. We've heard horror stories of cylinders of activated carbon that actually set off Geiger counters at a landfill and things like that. And I don't know, there might be one horror story like that, but it circulates through multiple people, so you hear it all the time. So there's some concern with those types of treatment systems, but generally speaking, these are things that are going to be put back out into the environment where they came from.
Thanks. How often should you get your well tested? You mentioned first time testing, but after the first time, like, is it an annual thing? Is it, every 5 years?
Mm-hmm.
How often should you be testing for these various contaminants?
Yeah, we recommend, and the State Division of Public Health recommends annual testing for coliform bacteria, every 2 years for heavy metals and nitrate, things like that. And then probably a 5-year interval for some of these other contaminants like the volatile organic compounds and radionuclides. And certainly if you have detections of those things, you may want to retest more frequently.
So we had a question through the chat. We're hearing a lot about PFAS. Any sign of that in Wake County?
Right. That's a great question. It's all over the news. Certainly there's a lot of PFAS around. We hear about it around Cumberland County where the chemicals are manufactured, and down in Wilmington where they're downstream of that manufacturing facility. I'd be surprised if it's not out there in the environment. However, at this point, our focus remains for Wake County on things that we know are present and that we know the health risks associated with them, like radionuclides. And we also know that very few people have ever had their well water tested. And so we try to focus on, getting people to get that initial test for things that we know what the health risk is. We know what to tell you about your results. PFAS is one of those where there's, there are dozens. Hayden can tell me how many PFAS compounds there are probably. And I think the EPA has established guidance levels or standards for 2 of them so far. So at this point, we're not doing the testing, and the testing for those dozens of chemicals is pretty expensive. And once you get those results, it's hard to find a definitive safe level to be shooting for if you're concerned about that. So it's out there as a concern. I don't want to minimize it, but I would encourage people to focus on, first start with the things that we know are present in wells in Wake County, and we'll be working with researchers like Hayden and others to see, how do we begin to learn about the prevalence of those contaminants, and hopefully learn, like from Hayden's research, what does that information about unknowns do to well user behavior? That was one of the things I thought was really cool about this study, is bringing in that human element. There's a lot of, technical science in this project, but I think it's really cool that Hayden and Dr. Nichols have brought in the human element of what do people do once they have this plot that says, well, we found these contaminants in your water, but we don't know how much is there. We don't even know maybe what they're called, what the health threat risks are, and so forth. How do you feel? And that's a really important part for us of, how we deal effectively with something like PFAS.
Hayden, you mentioned that with your research, you'll be communicating back with the people that you had the samples, and then with officials. What kind of plans do you have for making the research public to the general community versus like a science community?
Yeah, so obviously we'll hope to, present at scientific conferences and publish some of these results, but we also do want to work with Wake County and maybe even other neighboring counties, and share our results and do some public meetings to make sure that we make this effort valuable to public health officials and private well users themselves.
Awesome. Definitely interested in seeing more. For me, it was pretty surprising to see the difference between the two tests of how much was detected. You mentioned, there's financial assistance for people that need help. Is there programs out there for people that find like severe contaminants of their well to help them kind of mitigate that, or is it just that small financial assistance program you had mentioned?
Yeah, it depends on the situation. Generally speaking, if we find petroleum compounds in a well, we're going to be calling the Department of Environmental Quality and the folks who respond to petroleum contamination there. And, hopefully somebody else's property was the origin of that contamination in your well, because then they'll have, reason to go after a polluter and either make that person accountable for your contamination or access trust funds and things that have been set up at the state level to help fix that problem. We had an unfortunate case recently where a homeowner found volatile organic compound contaminants in his well water, and it turned out that before he purchased the property, there were activities on the property that are likely the source of his current well water contamination, and they were not disclosed to him when he bought it. And so unfortunately in that case, us calling up DEQ resulted in a letter sent to him. And, it's a difficult situation, but so it really depends. I bring up those couple of examples. And there are state funds to just directly pay for an alternate water supply. If there is a nearby municipal line, it can actually be run into your house depending on, again, what the contamination is and the existence of state programs to deal with that.
Cool, thank you. Going back to the HRMS, Hayden, do you know what the next steps are that people are working on to be able to know the quantities without having to do multiple tests?
Yes. So the biggest challenge there is getting standards. So to really with a good level of certainty know the concentration of these various chemicals that we're testing, you have to have a standard to compare it to. And so when we're talking about emerging contaminants that we haven't studied before, that we don't know, that's one of the big challenges. But it is something that there are researchers out there that are working on making those standards, getting those available, and working on developing or testing concentrations of emerging contaminants. It's just a slow process when there are thousands of features in chemicals.
Have there been any current studies on the effects of community supply wells on private wells for contaminants and for yield?
Wake County did commission a study with the U.S. Geological Survey back in 2009. There was a neighborhood in northern Wake County known as Norwood Oaks that was experiencing a lot of dry wells, and the county brought in the USGS to study water levels there and the potential interconnections underground between those individual wells and nearby community water supply wells. We do have that study on our website, wakegov.com/wells. We have a groundwater studies page where you can find that. What I'll say is without background data, it's very difficult to determine, without background data and extensive investigation, it's difficult to determine whether a well going dry is due to a nearby pumping well or simply due to drought, things like that. So it's quite a challenge to make those determinations. In terms of contamination, generally speaking, the operation of one well should not result in contamination of another one, unless we're working in a situation where there's some kind of contamination underground that is being moved by one well towards others. Generally speaking, there's a lot of due diligence, environmental site assessment work done before installing a well that would detect those types of problems first. Yeah.
All right, well, we're nearing the end. Give another minute in case everyone has any last minute questions they'd like to throw in. But I'd like to thank both you, Evan and Hayden, for speaking with us tonight. It was definitely very interesting. I learned a lot. I personally don't have a well, but my grandma has one. So I hear a lot from her of issues that she runs into with her well. Again, thank you so much for joining us tonight. Thank you all of y'all for joining us. For those of you that need EE credit, I will be sending out that form later this week, along with a link to this recording, in case you if you want to go back and watch anything. Again, thank you for joining us tonight. We really appreciate it. And we hope that everyone will join us next month for our April lecture.
Thanks for the opportunity.
Thank you so much.